Awesome. And second up, we have Jens Detrick from Victoria University.
Yeah, hey, thank you very much. Yeah, so I'm really, really happy to be here. I'm actually here quite often because I teach here. I'm not from industry, I'm from university, and I teach testing and a lot of other things here. And that one's going to be a little bit different because I'm not going to talk about testing now, I'm talking about static analysis. And the reason is that I'm starting to teach a course in trimester 2 on static analysis and all students that's highly industry relevant. So I thought I give this talk to make sure that's actually the case and I haven't been mind. So why you should be using static analysis, and Big Technic is already doing this. So what is static analysis? It's software quality assurance that's not based on testing or executing code, but you just build some sort of model of the code as it is without executing this, and then you reason about this and you try to find things that are bad and problems. Yeah. Cheers. Oh. There are some great examples of this that have been around for a long time, and most of you are probably using those every day. And the best example is a compiler. Compilers work great, they find a lot of bugs, and they are actually so good that it's a little bit of a challenge for us, because students after a year or so are convinced that if it compiles, it actually works, and there's nothing more to do. And of course, we all know better, but that turns into a real curse. The idea has been taken further for a couple of years. So there have been tools like linters, syntax checkers. You might have been using tools like PMD, checkstyle, and so on and so forth. And they are somehow not that great, and a lot of companies started to give up on them because they produce a lot of noise. So you get a lot of signals from those tools, they pretend to find a lot of bugs, but then you look at those bugs and you say, that's actually not really a bug. That is something we can live with, so they produce a lot of noise, a lot of false positives. However, recently there are also very, very good examples. And one example that works really well for a lot of people is Dependabot, and there are a couple of similar tools like Snike that look into your software supply chains. If you haven't really used it, it comes with GitHub, so if you have a GitHub project, it comes for free, there's nothing you have to configure. It runs in the background, and it looks into your software dependencies and the libraries you're directly or indirectly using, and cross-references this with vulnerability databases. And if it finds something, it will create a pull request, so it's a highly actionable outcome, and tell you, well, you're depending on a library that has a vulnerability, but here's the easy fix. If you accept the pull request, we just bump you up to the next version that has a fix for the vulnerability, and everything is fine. You can do it for a couple of similar situations, like checking for open source licenses. There are some licenses you don't want to depend on. So easy to action outcomes, they're really fast. That's actually not really difficult to do in this case, because you're actually not reasoning about code, you only reason about your project metadata. Your project settings like Gradle or Maven or whatever it is. They're very easy to deploy. You already have them because they come with GitHub. It's nothing you have to install. They are there as a service. They have a very low false positive rate and a very low false negative rate as well. Those two things are really core insight into modern static analysis tools. What happened now? I didn't touch anything.
Let's try this.
Did maybe our booking just expire or something and it timed out? Or?
We put some more money in the meter, I think.
Excellent, yeah. Okay, so false negatives are things you miss, and that's what testing is suffering from. You only test what you test, right? And it's never complete, and coverage, of course, is no guarantee that it is complete. Testing has false negatives. Static analysis tends to suffer from the opposite thing. You find too much, so you have false positives, but that's also a problem, because then it creates issues you have to deal with that block resources you rather want to spend on other things. So the pitch is really that there's a new generation of static analysis tools that addresses a lot of those things and does really, really well. And what you can expect from those static analysis tools, what did you do? Manual lights or?
Oh, I don't do this, and now you go back. Let's try that again. I don't know. Anyway, 2 minutes.
It's maybe my dark background. Okay. So You have low false positive and negative rates. They are usable as a service. They are fast enough to run in continuous integration. They often work for multiple languages, so they're language agnostic. They are driven by big tech. There are a couple of tools like Facebook Infer, GitHub LGTM, Google Error-Prone, to name a few. And you can often write custom analysis as database queries because you basically create a database from your code and you query it in SQL style. So you can easily write custom analysis. So in my title, I mentioned big tech is using this, and of course you won't be able to write down those URLs, but if you just Google for static analysis at Google and static analysis on Facebook, you find two really, really good articles. They are not very technical, they are more managerial, and that will provide some further insights. So testing and static analysis really go nicely hand in hand together. That is my overall message. Final slide, Aaron. Academia and industry, talk to us. There are a few colleagues here from Canterbury over there, from Massey over there, some more people from Victoria, internships, guest lectures, government-funded research projects. That's all stuff we are interested in. We also do a lot of testing, so there are several government-funded research projects on test flakiness. I had a little discussion on Slack on this. I'm interested in more insights on generating tests from faults for crash reproduction in JavaScript. That's something that runs here. Fuzzing web application, something Oracle funds. There's a project in Auckland on testing without oracles funded by Facebook. So there's a lot of stuff going on in universities. Please talk to us. We are really keen, and I'm around later, and I can kind of dispatch you or route you to the right people for those questions. Thank you.